Welcome to chemistry online class. Let's start the topic basic concepts of chemistry. The previous class discussed about elements and orbitals. Today discuss about filling of orbitals. Filling of orbitals. The electron, how to fill in the orbitals. In an atom, nucleus, the electron revolves around the nucleus. K orbit, L, M, N orbit, S orbital, sp orbital, sp d orbital, and sp d f orbitals. The electron filling of orbitals. Electron filling of orbitals. In an atom, the electrons are filled in the various orbitals according to Alpha principle, Pauli exclusion principle, and Hund's rule. Are you right? Alpha principle, Pauli exclusion principle, and Hund's rule. The first principle, Alpha principle. Alpha principle. Define Alpha principle. The atomic orbitals are filled in the increasing order of their energies. The atomic orbital S, sp, spd, sp, df. The atomic orbitals are filled in the increasing order of their energy, starting with the orbital of least energy. The electron filled with the least energy to higher energy, starting with the orbital of least energy to higher energy. Are you right? The least energy orbital found in near the nucleus. Near the nucleus. The least energy to higher energy. The least energy orbit to higher energy. So, the atomic orbitals are filled in the increasing order of their energies, starting with the orbital of least energy. How to measure least energy orbital to higher energy orbitals? The students trick for least energy to higher energy. Draw the triangular structure. And 5, 1, 2, 3, 4, 5 horizontal line. 5 horizontal line. 5 horizontal lines. The oneness orbital is the first orbital. The oneness orbital is the first orbital. Oneness, 2s, 3s, 4s, 5s, 6s, 7s. 1s, 2s, 3s, 4s, 5s, 6s, 7s. The second orbital, 2s and 2p. So 2p, 3p, 4p, 5p, 6p, and 7p. Then leave the first two horizontal line, then write 3d orbitals. You write? Leave the first two horizontal lines, then write 3d in the next line. 3d, 4d, 5d, and 6d. Then leave other two lines. Then write 4f orbitals. So leave two horizontal lines, then write 4f. 4f, 5f. The increasing order of orbitals. 1s, 2s, 2p, 3s, 3p, 3s, 3p, 4s, then 3d. The 4s orbital is least energy than 3d orbital. 3d, 4p orbitals, 5s, 4d, 5p, 6s, 4f. The 4f orbital is less energy than 5d orbitals. 4f, 5d, 6p, 7s, then 5f, 6d and 7p. The periodic table are also arranged in base of the alpha principle. The periodic table, the first periods or row contain 2 elements. The second and third row or periods contain 8 elements. The first, second, third and fourth and fifth periods or row contain 18 elements. 18 elements. And sixth and seventh, 32 elements. 32 elements. 32 elements, incomplete row. The first row, hydrogen and helium, s orbital. The s orbital having maximum 2 electrons. The s orbital having maximum 2 electrons. The hydrogen 1 electron, helium 2 electrons. So 1s1, helium 1s2. The second row contains 8 elements. S maximum 2 electron, P maximum 6 electrons. S 2 electron, P 6 electron, D 10 electron and F 14 electrons. So the first least orbital, 1s orbital contain 2 electrons. Are you right? 2. The next 2 plus 6, 8 electrons. So 8 element presents in the second table. And there 3s 2 electrons and 3p 6 electrons. Total 8 electrons. So 8 element presents in the third period. And fourth period, S 2 electrons, D 10 electrons, P 6 electrons, totally 18 electrons present in the fourth orbital. So fourth row of periods contain 18 elements. 18 elements. The fifth are also 18, 2, 10, 6. The sixth row of periods, 2, 14, 10, 6, 32. 32. So, sixth row of periods contains 32 elements. 7s2, 5f14, 6d10, 7p 6. So, 32 electrons. So, 32 element presents in the seventh period. So, alpha principle, the atomic orbitals are sp, d, f. The atomic orbitals are filled in the increasing order of the energies, starting with the orbital of least energy. So, least energy to higher energy, the electrons are filled. The increasing order, the trick for increasing order. For example, carbon, atomic number 6. Say neutral atom carbon, the number of protons and number of electrons are equal. So, number of electrons is equal to 6. Now, how to fill the electrons in the orbital? The orbitals, the increasing order of the orbital. 1s2. The s orbital has maximum 2 electrons. 1s2. 2s2. 1s2, 2s2. The 4 electrons are filled. And 1s2, 2s2, 2p. Totally 6 electrons. Already filled 4 electrons. So remaining 2 electrons. 1s2, 2s2, 2p2. Now another one example, scandium or titanium, anyone. Scandium 21. Scandium 21. 21 protons and 21 electrons are found in the scandium atom. Double the electronic structure of scandium. 1s2, 2s2, 2p6, 2p6, 3s2, 3s2, 3p6, 3p6. How many electrons are filled? 6 plus 2, 8, 8 plus 2, 10, 16, 18. 18 electrons are filled. How many electrons are there? 21 electrons. So 4s2. The 3d orbitals are high energy than 4s orbital, or 4s orbital are least energy than 3d orbitals. So first filled with the 4s orbital, then 3d. 3d 1. The correct electronic configuration of scandium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d 1. Right? Half of principle. The next principle, Pauli exclusion principle. Pauli exclusion principle. Yeah, atomic orbital, s orbital, p orbital, s orbital, p orbital, d or f orbital, any orbitals. The atomic orbitals can accommodate only 2 electrons. So 1 orbital, 3 orbitals. Suborbitals, 3 orbitals. The atomic orbitals can accommodate only 2 electrons. Only 2 electrons. So, and these 2 electrons must have opposite spins. Each atomic, subatomic orbitals contain maximum 2 electrons. And these 2 electrons must have opposite spins. Yes, s orbital having maximum 2 electrons, thus 2 electrons must have opposite spin. Okay, so each orbitals have maximum 2 electrons. That the 2 electrons must have opposite spin. Opposite spin. The Pauli exclusion principle. Hund's rule. That principle, Hund's rule. The atomic orbitals of equal energy. The p orbital, 3 suborbitals, px, py, and pez. P orbital, suborbitals, px, py, pez, suborbitals. The atomic orbitals of equal energy, px, py, and pez are px equal to py equal to pez. Equal energy. The atomic orbitals of equal energy, the pairing of electrons does not take place until all such atomic orbitals are singly filled with electrons having parallel spins. The atomic orbitals of equal energy, pairing of electrons. The pairing of electron does not take place. Until all such atomic orbitals are singly filled. Does not take place pairing. So until all such atomic orbitals are singly filled with electrons having parallel spin. Are you right? The atomic orbitals of equal energy, the pairing of electrons does not take place. The pairing of electron does not take place until all such atomic orbitals are singly filled with the electrons having parallel spins. For example, nitrogen, atomic number 7. The electronic configuration 1s2, 2s2, 2p3. So, 1s orbital having 2 electrons in opposite spin. According to Pauli exclusion principle, 2s orbital having 2 electrons and 3p orbital, 2p orbitals, 2px, 2py and 2pz. The 3 suborbitals are equal energy. The atomic orbitals of equal energy, pairing of electron does not take place. The 3 electrons cannot found in this method. It's a wrong way. Until all such atomic orbitals are singly filled with the electrons having parallel spin. Right? Singly filled. Nitrogen. Now oxygen, atomic number 8. The electronic configuration 1s2, 2s2, 2p4. The 1s orbital having 2 electrons, the 2s orbital having 2 electrons, and 2p orbital having 3 equal suborbitals, 2px, 2py and 2pz. So the 4 electrons, the first filled in single electrons. The p orbital in 3 suborbitals, 2px, 2py, 2pz. Okay, the 2p orbital having 4 electrons, the 1, 2 and 3. The atomic orbitals of equal energy, pairing of electron does not take place. Until all such atomic orbitals are singly filled with the electrons having parallel. So the last 4 electron, the 4th electron filled with the 2px orbitals. 2px orbitals. To write the first rule in Hund's rule. First minute. Stability of orbitals. According to Hund's rule, the half fill, the p orbital having maximum 6 electrons, but a half fill p3 half fill. D orbital having maximum 10 electrons, the half fill d5. The f orbital 14 electrons, half fill f7. Right? So the half fill and full orbitals are more stable than partially filled orbital. P1, P2, D1, D2, D3, D4, D6, D7, D8, D9. So partially orbitals, half fill and full orbitals. Right? The half fill and full orbitals are more stable than partially filled orbitals. The example, nitrogen and oxygen, beryllium and boron. The nitrogen 7, 1s2, 2s2, 2p3. Oxygen 1s2, 2s2, 2p4. The maximum electron in p orbital is 6. The half fill electron 3. So the nitrogen having half filled 3p orbitals, but oxygen having partially filled p orbitals. So half-filled orbitals are more stable than partially filled orbital. So nitrogen is more energy than oxygen. Beryllium 1s2 2s2. Boron 1s2 2s2 2p1 4 5. The beryllium having completely filled 2s orbital, but boron partially filled 2p orbital. So beryllium is more stable than boron. More stable than boron. So according to Hund's rule, the half-filled and full-filled orbitals are more stable than partially filled orbitals. The next principle, the chromium and copper. The electronic configuration of chromium and copper according to Hund's rule, chromium and copper. The atomic number chromium 24. The expected configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. Expected configuration 4s2, 3d4 according to Alpha principle. But according to Hund's rule, the actual electronic configurations 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. Already you know that the half-filled and full-filled orbitals are more stable than partially filled orbitals. The 3d orbital having 4 electrons, to occurring one more electron to reach half-filled d orbitals. So s orbital, one s orbital goes to d orbital, and d orbital to reach half-filled orbitals is more stable. The next one example, copper. Atomic number 29. Electronic configuration according to Alpha principle 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. The 3d orbital occurring one more electron to reach 3d10, completely filled orbitals, more stable orbitals. So 4s orbital, the 4s electron, one 4s electron goes to 3d orbital. 3d orbital according to Hund's rule, the full-filled orbital is more stable than partially filled orbitals. So actual electronic configuration of copper 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10. 3d10. So to reach half-filled or full-filled orbital requiring one more electron, that electron goes to 4s2, 3d orbital. Right? Electronic configurations. Electronic configurations. The electrons, how to fill in the orbitals. S, P, D, F orbitals. In an atom, the electrons are filled in various orbitals according to Alpha principle, Pauli's exclusion principle, and Hund's rule. Right? The electronic configuration of hydrogen. Hydrogen, atomic number 1. So 1s1. 1 electron. Helium, atomic number 2. 1s2. The s orbital having maximum 2 electrons, and p orbital having maximum 6 electrons, and d orbital having maximum 10 electrons, and f orbital having maximum 14 electrons. So 1s2. 1s2. Lithium 3. 1s2. 2s1. 1s2. According to Pauling exclusion principle, each orbital having maximum 2 electrons. The 2 electrons are present in opposite spins. Opposite spins. 1s2, 2s1. 2s1. Lithium. So hydrogen, helium, lithium, beryllium. Beryllium 4. 1s2, 2s2. 1s2, 2s2. According to Hund's rule, the completely filled orbitals are more stable than partially filled orbitals. Boron 5. 1s2, 2s2, 2p1. So 1s2, 2s2, 2px, 2py, 2pz. So 2px orbital having 1 electron. Carbon 6. 1s2, 2s2, 2p2. 1s2, 2s2, 2px, 2py, 2pz. According to Hund's rule, the equal energy orbital will single electron, then pair. Okay, carbon. Nitrogen 7. 1s2, 2s2, 2p3. The half-filled orbitals, half-filled 2p orbital is more stable than partially filled orbitals. 1s2, 2s2, 2p3. 1s2, 2s2, 2px, 2py, 2pz. To write according to Hund's rule, 2p3, 2px1, 2py1, 2pz1. Equal energy orbitals. Oxygen 8. 1s2, 2s2, 2p4. 1s2, 2s2, 2px, 2py, 2pz. According to Hund's rule, the equal energy orbital having single electron then pair. 1, 2, 3, the fourth electron entered to 2px orbitals. Fluorine 9. 1s2, 2s2, 2p5. 1s2, 2s2, 2px, 2py, 2pz. 1, 2, 3, 4, 5. Neon 10. 1s2, 2s2, 2p6. The completely filled orbitals more stable. Neon is a inert gas, more stable element. 1s2, 2s2, 2px, 2py, 2pz. 1, 2, 3, 4, 5, 6. So neon, right? Sodium, atomic number 11. 1s2, 2s2, 2p6, 3s1. according to alpha principle. 1s2, 2s2, and through 1, 2, 3, 4, 5, 6. 3s1. Magnesium 12. 1s2, 2s2, 2p6, 3s2, 3s2. Magnesium is more stable, completely filled orbitals. Magnesium, sodium, magnesium, aluminum, titanium. 1s2, 2s2, 2p6, 3s2, 3p1. According to alpha principle, aluminum, silicon, 14 silicon. 1s2, 2s2, 2p6, 3s2, 3p2. 14, 15 phosphorus. 1s2, 2s2, 2p6, 3s2, 3p3 phosphorus. Sulfur 16. 1s2, 2s2, 2p6, 3s2, 3p4. 10, 16. Sulfur. Chlorine, atomic number 17. 1s2, 2s2, 2p6, 3s2, 3p5. Argon 18. 1s2, 2s2, 2p6, 3s2, 3p6. Okay, next 18 argon. 19 potassium. 19 potassium. 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. The 4s orbital is least energy than 3d orbital. So 4s1. Calcium 20. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Okay. Okay, students. The element 21 to 30 electronic configurations. Homework to write. Thank you. We'll meet next class.